last method for volumes. And then there's another type of problem in this section, finding the surface area of all these three-dimensional shapes. We'll talk about that tomorrow.
Why is this one section?
I don't know. So it's integral from a to b of 2 pi r h. We'll say like dx. Alright, so we're going to do the same volume here using a different method. Okay, so on the tester quiz, if you're asked to find this, the easiest way to do it would be to use the disk method. I wouldn't make you do this in terms like using the shell method, but here's how you would do it using the shell method. Alright, so what you have to do is you draw, if we're going, we're going around the axis. So you draw a line parallel to the axis of revolution, and then you can connect that to your axis of revolution. And this is going to be your height, and this is going to be your radius. Okay, so the height is parallel to the axis of revolution. So what we're making is a shell. Okay, so another shell would look like, you can imagine, we're like stacking the shells. They're hollow cylindrical shells to form the volume.
How are they hollow? Because why would they be solid if you're? And how are you getting all of the volume if you're?
Because you're integrating it.
Okay.
So like it'll start out like super small, and then it'll go,
The radius will keep changing to.
yeah. So like then it'll just get bigger and bigger and bigger.
So each one of these is a shell. Okay, so imagine a circular shell, and if you add all of them up, you'll find the volume.
Oh, you finally actually have a physical
Right.
example?
So each one of these pieces of paper wrapped around is hollow, and if you stack them, you'll find the volume.
Why is it
Okay.
hollow? Why is it hollow? Like, why does it not give you a solid? Like so.
It does give you a solid, but each individual, infinitely many hollow shells will create a solid. Each one of these sheets of paper is hollow if you wrap it around. You stack it. Okay? So I don't expect you to completely visualize it right now.
That was a pretty good visual.
So, do you notice that each change, we're changing this way, right? So that means our integral is going to be with respect to y.
Oh.
So it's the opposite of what we have done. Our integral in this problem, since I'm going around a horizontal, will be with respect to y. So it is 2 pi r h dy. So if it's dy, we're going from here to here. This ordered pair is what? 4 comma 2, right? The square root of 4. So we're now integrating from 0 to 2. Here to here, because we're going dy. So what's my radius here?
Square root of x.
It's the square root of x, right? This is y equals the square root of x. But we're not going to put square root of x right here.
So y squared.
Why?
We're going to put y there. Because y is equal to the square root of x. This is y. It's also the square root of x. So if we're integrating with respect to x, we would use the square root of x. We're not, we're integrating with respect to y, so we're going to use y right there. That's
This is
my
y.
radius.
It's the square root.
Maybe why?
Why isn't it y squared?
Anytime you find the distance from the x-axis up to a graph, it's always going to be y.
Because you're not finding pi r squared, because that would be finding the area of the
Yes.
circle. It's 2 pi r.
The disc method is really just the first method.
All right.
It's just done with circles.
So now we have to
Always.
find the height of our cylinder. Okay, we found r. Now we have to find our height, how long our cylinder is, right? Well, what is this distance right here? That is x. Very good. Anytime you go from the y-axis out, that is x. How long is this entire thing?
H minus
4.
X.
This
4
whole
minus
thing.
x.
This whole thing is 4. So how long is that? 4 minus x.
Oh,
Okay,
why-
so that's our height. But we can't do 4 minus x, right?
4 minus y squared.
Good, so we need to figure out what it is. So square both sides, x equals y squared. So our x is y squared, so it's 4 minus y squared. If you plug that into your calculator, you'll get the 8 pi, is that what you said?
Wait, so in the red, shouldn't that be dy? Or is that, it's not always gonna be?
Yeah,
I'm
so
gonna let this online instead.
if we go around, there's 2 versions of it, that should be y in this case.
Okay,
If we're going around a vertical, then you'd go dx.
So just the opposite of whatever.
It is the opposite. Because we're stacking them vertically here, so that's a dy.
So why would we ever use this instead of
Really good question. So this seems, some students end up gravitating toward the shell method, most do not. Like you could do that problem right there with the shell method, and some people have a better understanding, maybe mentally or sometimes it just turns out to, your integrals turn out to be a little bit easier. So there's that, but most students try to avoid the shell method unless you have to. So why would we ever have to use the shell method? If you have an equation, not even a function, if you have like x equals y cubed minus y squared plus 2y minus 1,
oh dear.
and so if we're going to integrate this, let's say we have x equals 4 or something like that, and I'm going to make this up. Let's say it looks like this. And we're going to grab that much of it. Okay? And do we want to integrate this with respect to y or x?
X. Wait, no.
If you're going to integrate with respect to y, okay, I'll say it again. If you want to integrate with respect to x, you'd have to solve this for y, right? And write y equals in terms of x. There's no way we can do that. There's no algebraic way of solving this for y and writing it in terms of x. Okay? So we don't have a choice but to integrate with respect to y, because it's in terms of y already. You understand that?
Okay.
Okay, so if we're going to revolve this area around the x-axis, yeah, we can't use the washer method, right? Because we'd be integrating with respect to x. So if we're going to go around the x-axis here, we would have to use the shell method, because then we would be integrating with respect to y. Okay, so there's an example in the book. And we'll do one from your assignment, so you can write this down right now. Let's look at number,
So would there be problems like this on the quiz where you have, I think you said
let's do number 39 together. That's not an example where you have to use the shell method. Well, let's try it. y equals x looks like this. Negative 1/2 x looks like this. X equals 2. Looks like this. So we have that area. And we are going around the y-axis. Alright, so they tell you to use the cylindrical shell method. The first thing you want to do is draw a line segment through the area of the region parallel to the axis of revolution. And that's going to be our H. Then connect your height to the axis, and that is your radius. And if you don't want to draw the fancy shells, that might be sufficient for you. That's your R, that's your H. Okay? If you wanted a visual, there's our shell. Alright, so dx or dy?
dy.
dx, it's around the y-axis.
dx because we're on the y.
Right. So we're gonna go dx. So and this is 2. So I can already go 0 to 2, 2 pi r h dx. And we haven't really done much, but we've got an integral set up. All we have to do now is to figure out r and h. In this, I intentionally write this so that you don't write y stuff in it. We're dx here. So what is my radius?
2 minus or just x.
It's just x. Anytime you go out from the y-axis, it's going to be x. Okay, my height in terms of x. Well, it is this y minus that y. So it's that one minus that one. That y minus x. So
So x
That
plus x
is-
equal 2.
y equals x. And this is y equals negative 1/2 x. So what's my height?
3 has that.
That's right. Because it's that one minus this one. So that's 1.5, 3/2 x. Okay, and I would argue that it'd be easier with the shell method here rather than the washer method, although it's not necessary. Because the washer, you'd have to do 2 different integrals, right? Can you see that? You have to find this top, or there's your big R, there's your little r. Then you've got big R, little r. 43, let's start 43, and we're going to do one that's not the axis. Why don't you try 43A, so you can set it up. Shell method. Do you see that we could not use the washer method here? It's impossible. Because you'd be, your big R and your little r is the same relation, same equation. So you can't wrap that around the
Unless
x-axis.
you
We
make
certainly can't integrate with respect to x, right? You'd have to solve that for y, which is impossible.
Unless you just made a regression equation that went up into that point where you would stop integrating.
Regressions aren't perfect.
Regressions are perfect.
No, they're not.
Alright, so we're going to use the shell method. So it's integral of 2 pi r h. And are we dx or dy?
Why?
dy, good. It's a horizontal axis of revolution. So for dy, we have to go from here to here, so that's 0 to 1. That's kind of given to us, which is nice. We draw our height, which is parallel to our axis of revolution. And then connect our height to the axis, and that's our r. All right. what's my R here?
Why? Why?
Anytime we go from the axis up, it's gonna be Y. The axis out, it's gonna be X. So this is Y, which we can leave it as Y. Very good. And this one is X,
But we
which is actually that. How many got that right?
close. Kind of.
Close?
Minus the R and H.
Alright, so let's revolve it around Y equals 1. Alright? We're going around Y equals 1. See if you can set up an integral for that. 2 pi. My H is still the same. This is my new R. So your H is the same. 12 times y squared minus y cubed, dy. The R is the only thing that changed. That distance right here is 1 minus y. This is y, that's 1 minus y.
Oh my god, it's so